Welcome to the Tech Arena Great Debate. My name's Allison Klein, and today I am so delighted to be featuring three experts from the industry, Mohan Kumar, Kelly Mullick, and Erica Thomas. I'm going to have them introduce themselves. Mohan, why don't you go ahead and go first?
Thank you, Alison. I'm Mohan Kumar. I was a fellow at Intel for close to a decade, focusing on server innovation, including cooling and how data centers and AI is built out. Currently, I'm in a stealth mode startup, serving as the chief architect and VP of technology.
Awesome. Kelly, why don't you go ahead and introduce yourself?
Thank you, Allison. Yes, I'm Kelly Mullick. I have a technical background in chemical engineering and fluid flow dynamics, and I was also at Intel for many years. I served in both technical and business roles. My last role at Intel was around infrastructure, thermal management, and developing liquid cooling solutions and the business strategy for that. Since then, I've moved on, and now I'm the president and CEO of my own company, Avayla, and I do consulting around AI data center infrastructure and implementation of those new scaled infrastructures, working with clients.
Fantastic. And Erica, last but not least, Erica, why don't you introduce yourself?
Hi, I'm Erica Thomas. I'm the executive director of the Liquid Cooling Coalition, which is a policy advocacy organization in Washington, D.C. Work for my parent company is called Coefficient. And I also support another coalition we run called the AI Infrastructure Coalition. Before joining this group and starting the Liquid Cooling Coalition about a year and a half ago, I ran the Green Grid for a few years, which does data center energy efficiency and data center energy efficiency metrics. But best known metric that they produced is the power usage effectiveness metric. And while I was running that, I was also working for the Information Technology Industry Council. And before that, I was a diplomat covering energy policy globally.
Erica, I didn't know this about you about Green Grid. I was involved in the Green Grid when it first started in like the mid-teens. So fantastic. We have some shared history. The three of you have just written an amazing report that Tech Arena was so glad to publish on the future of AI data centers. And in it, you deliver so many interesting takeaways in terms about the deep challenges in designing infrastructure for AI in particular. I'm just going to start with a basic question of what are these challenges in terms of delivering infrastructure that's actually going to scale for AI and comparing that to traditional data center infrastructure? Who would like to start?
Mohan, do you want to start?
I can go. Since I have experience building both of them. So essentially, as AI started, AI has been pushing the limits of what needs to happen in terms of. I have to take you down to the silicon design and tell you how AI silicon chips like a GPU or an AI accelerator are designed. They are often stacked. They are pretty large chips. They require a lot of power, and of course, where there is power, there is heat, and that heat needs to be dissipated. And so the challenges went, uh, they grew exponentially overnight. So just to give some frame of reference, a CPU probably, outputs in the 300-watt range. A GPU could easily output in the 1,000-watt range. That's one single one. And typically you have 8 GPUs in the system. Now you're looking at 8,000 watts coming out of a single box. The whole box was 1,000 watts before. So therein lies the crux of your problem. Now multiply that by the number of systems times the number of racks times the number of data centers. You have a big power problem and you have a big cooling problem on your hand.
Now let's break this down further. Is this problem limited to hyperscale? Is this a problem in neocloud? Will this extend into enterprise as enterprise starts adopting AI? Is it also involved in HPC clusters as HPC starts integrating AI into workloads? How would you look at that? Kelly, do you want to take that one?
Sure. So I would say right now, predominantly this is impacting the hyperscalers. They are the ones that are the market that's really designing and innovating the fastest, and they're dealing with these scale challenges, and they're building clusters at scale. So for now, I would say that that's predominantly the area of focus or the market where we're seeing these challenges, but it is going to trickle down into several markets. And because we're innovating so fast, we're going to see these challenges hit other markets sooner rather than later. And the predominant reason we're seeing that is that AI clusters really require a complete redesign of the data centers. Traditional compute, if you want to call that, were really designed in a way that they could each rack could operate interdependently.
Mhm.
So the rack next to it, it really didn't matter the type of workload or the type of what you were running in that rack. They could run independently of each other. Whereas with AI clusters, because you need to reduce the latency in order to have a performant cluster, these racks have to operate in a serial fashion or in serial so that they can maximize the power from each rack. And so that's really wherein the challenge lies, is that you have to design for that type of cluster for the maximum performance.
Now, you guys have introduced some really interesting takes on how you apply that within clusters in the data center, and we're going to get into that. But I just want to start with one startling statistic. GPU thermal design is pushing rack power to 600 kilowatts and beyond. Some of us were at OCP Dublin a couple of weeks ago, and this was something that was discussed broadly in terms of the work of the organization. Why don't we break down where air cooling fails and what trade-offs we're looking at as people start implementing different types of liquid cooling alternatives to the equation?
I can start with
Yeah,
this, Mohan, and maybe you can comment, and then maybe I think also that that dovetails into some of the work that Erica's seeing as we're transitioning from air to liquid. So really, air starts to max out around 350 to 400 watts, and then you're really into the realm of where you need liquid cooling, and that's for a single CPU and GPU. And we, as Mohan said, we're at that limit right now with the latest CPUs on the market today, and so GPUs really are required to have liquid to support them. And there's many different types of liquid that can support that. And so I would say liquid, then, you have different types of liquid cooling that can support clusters. And I think we're in that realm now where we're looking at which are the best types of advanced cooling solutions to support these AI clusters.
yeah. I think that was a good. So Kelly covered the basis there, right? So the we are we're entering a phase where it is not so much that why can't you cool with air? It's just that cooling with air means you're running a fan, and that fan speed essentially is drives power. At some point, it's no longer practical for you to drive that because most of the power that you're supplying to your server platform is going to cooling needs and not to powering the useful stuff. And at which point, in the 300 to 500 watt space, you basically say, no, you need to go to an alternative cooling technology. And the technologies that we are looking at right now are cold plates, where some kind of fluid is circulated inside those plates to cool the hardest components. And and then the other alternative is immersion, where we dunk the whole thing into a non-conducting liquid, and then the liquid conducts the heat away.
So, Erica, I'm going to bring you into this. Mohan and Kelly are describing some really innovative technology and things that have not been done before in data centers. To put in perspective, there's over $1 trillion expected in investment in AI data centers around the world. And nation states are starting to make plays in terms of the investment in this strategic technology. What are the biggest misconception policymakers have about changes needed in scaling data center infrastructure for AI, and how can the industry better educate stakeholders as we're looking at this massive transformation?
So the biggest misconception that policymakers have about this coming transition is they generally don't have any idea that it's coming. And so that's the role of an organization like Liquid Cooling Coalition and the AI Infrastructure Coalition, which I also support, that is to educate policymakers about this change. The LCC got started, Liquid Cooling Coalition got started a little over a year and a half ago, with the goal of just getting people to realize that liquid cooling exists and that it's not just in a lab and you should do it. The world has changed dramatically since then, and now the densities have risen so quickly that there's no longer a question whether you're going to need liquid cooling at some point. And there's been all kinds of technologies that now are getting adopted. It's moving at record speed. But because it's moved so quickly, there's still people even within some of the big companies that don't even understand that this has happened so quickly. You know, certainly those are the data center parts of the large companies knows that this is happening and what's going on, but not necessarily their policy shops. So what we're doing is we're going ahead and educating policymakers now, and we're also educating government relations teams within large companies just to make sure that they're aware that this is coming and pre-positioned to take action as needed, understanding that if we don't get this right, that, you know, it'll affect US competitiveness writ large. So understanding that this giant transition needs to happen, and that it may require support in some way, we're here to provide that support. That said, specific needs have not yet been identified because there's just so many different technologies going so many different ways that there's not an agreement of what exactly is needed at this stage. But we know that the policies will likely come and be needed quickly. So we're making sure the stage is ready for that transition to happen.
Now, you guys introduced cold plate immersion, hybrid liquid cooling systems all in play as we make this air to liquid transition and see what the future holds. You know, I think that this is being called a great debate because everybody's got a question of what is going to emerge as the dominant design for AI clusters over the next 3 to 5 years and why? And is there one that will emerge as the dominant player in that time frame?
Let me start and then I'll let Kelly and Erica chime in from their side. As we transition from air to liquid, it is going to, the fastest path is to go to cold plates, because cold plates will take care of the hardest components in the platform, which is currently the GPU. So that's the path that we're headed in. And then there are two types of cold plates. There is single phase and two phase. But eventually we want 100% heat recovery, meaning we don't want a combination where, in spite of providing a cold plate, I'm still have to air cool the system for the other components that are in there. That would require us to, drive us towards something that's a hybrid-based system. And also, cold plates have their limitations, and when we get to those limitations, you're looking at a hybrid future, in my mind. Kelly, your thoughts?
Yeah, I agree with you, Mohan. I think in the short term that we are in 2025, it is single phase cold plate technology that's scaling. But if you look at some of the research that was shared at the OCP summit, we saw that inflection point for cold plates where we really saw that scale happened in 2023. And similarly, an analysis was done and shared at the summit by one of our colleagues, Rolf Brink from Promersion. And his analysis showed that immersion cooling technology, where you have the the whole system or the whole chassis that's dipped within some type of fluid or using a non-conductive dielectric, that same inflection point is predicted to happen around 2028. So I see a lot of growth and a lot of interest in all of these technologies. And I will say also that as the TDPs continue to rise exponentially, that there's a lot of interest in two-phase technologies as well. There are challenges with two-phase technologies in some of the fluids, but there's been a lot of innovation in that space. There's also technologies, immersion type of technologies that use a rack design that don't necessarily use a tank. And there's a lot of advantages to those type of technologies as well. So I really see in the next 5 years a combination of technologies, hybrid technologies. There's also a type of hybrid technology that's using a cold plate and an immersion tank. These are also technologies that I see in this hybrid type where you have more than one cooling solution supporting your rack. So I really think it's going to be a combination of technologies. Personally, I think the rack-based solutions will scale more just because that's what most infrastructure is in a rack form factor. But I think we're going to see a combination of those technologies. And I think Mohan had it correctly when he said 100% heat recover is really going to be the focus of the future.
And I'm going to take a half step back because, as Erica said, this space is moving so quickly that sometimes people can't keep up. Can you just give us a quick definition, Kelly, on single phase and dual phase dielectrics?
Sure. So it really has to do with single phase. It means one phase. So you're essentially in the liquid phase. And the boiling point of that dielectric is usually around 150 degrees centigrade. And in a two-phase technology, you have essentially a closed tank solution. And the boiling point of the fluid is around 50 degrees centigrade. And so you essentially have the fluid evaporating onto condenser coils inside the system. Then those condense down into the liquid phase with the support of surface coatings that will promote that phase transition and then come back as liquid back into the tank. And so that's a much better heat transfer, and that's a lower, what we call lower latent heat of vaporization, meaning that shift will provide more enhanced cooling within the system.
Thank you. Now we're going to shift a little bit and talk about the data centers themselves. You gave this great vision of thinking about not just single rack, but rack to rack considerations in terms of design. AI racks need to operate in serial. How does that affect both the physical layout of the data center and redundancy planning? Mohan, do you want to take this one?
Yeah, absolutely. So yeah, AI data centers are unique in that AI systems are unique in that they are operating together as one entity, regardless of how many systems. And sometimes they go across racks and they operate as one entity. That basically means you have cabling that goes across these guys to make them behave as one because there are high-speed interconnects that are in place. And you also you view that entire full component, whether it's two racks or whatever the size is, as one entity, and that's what you have to provision for in your data center in terms of power. So you mentioned OCP Dublin. We talked about emergence of a 1 megawatt rack. It's a two racks that are sit together in tandem that consume 1 megawatt. That's kind of where we are going towards. So we need to be able to supply that kind of power into it. We need to be able to cool that rack while all the interconnects are in place between these racks, between these two racks and between all the other racks. There is usually the high bandwidth connection. There is what's called a backend network that connects beyond the high bandwidth network. And then there is a front end networking. So a lot of cabling that goes into this. In fact, just an anecdotal thing, some of these systems, once you open them, it takes 3 technicians to pull down the wires to be able to put the lid back on.
Wow. So when you think about that challenge and you think about NeoCloud, and we've written about NeoCloud on Tech Arena, it is a very important topic right now in a way we're scaling AI infrastructure. If you're building out greenfield data center space from scratch for AI training workloads, and you take what you just talked about, Mohan, and apply it, what are the new AI design rules that should become best practices in this space?
I think you really have to think about the key. There's several technical challenges. One of the challenges is because of all of the cabling, it's
Mm-hmm.
very difficult to get any kind of airflow in between, where you need to use air to cool the rest of the rack, so to speak, outside the CPUs and GPUs that are cooled by cold plate. So in the next, my prediction is the very next NVIDIA design after the GB200 is going to be some sort of hybrid design, potentially cold plate with immersion or some sort of air assisted cold plate designs. So I think that that's one key challenge, and I think one of the other real challenges is the power that is going, not only the power for cooling, because we're talking about liquid cooling, but also the power that's really required to support those solutions. Though that power load is increasing exponentially, and many of the hyperscalers are really focused on different types of power to support the data centers, whether it's sustainable power solutions, more nuclear options, different, just different options to really look at that. And so I think that's something that we need to look at and consider from a sustainability perspective.
Since you brought up sustainability, I'll bring up heat reuse. One of the things that has been talked about a lot is that the data centers generate a tremendous amount of heat that could be put to good use. What are the most promising applications you're seeing for repurposed thermal energy, and what infrastructure needs to be in place to make that real?
So I did some of this work with partners in my previous role. So the data centers that are in Nordic countries have
Mm-hmm.
been leading the world on this thing because apparently they have a hot water loop system that supplies hot water to your homes. And what you do is to reject the heat from the data centers into that hot water system. So it takes the heat away and heats up water that gets supplied to homes in these countries. Here in US, the kind of things that we have done are heating up a swimming pool in the nearby neighborhood by just rejecting the heat into the pool's heating system. The other thing that we have done is we are typically many of the data centers are located in remote areas, and so you just create a greenhouse and pump the heat into the greenhouse. So even when you're in colder climates, you can keep yourself supplied with growing vegetables and fruits on a much better basis. And not only that, it cuts down on carbon to move the food from elsewhere into your town, which you'd have done otherwise because you live in a colder climate.
Erica, I think heat reuse is one example where the EU has taken a foot forward in terms of regulatory mandates around efficiency of data centers and different policies associated with data centers. How do you see the US market learning from this progress in Europe?
I see US companies learning from Europe, because most of these companies are, certainly the largest ones, are global. And so what they're going to be doing in Europe will inform them, and hopefully they'll see the opportunities that heat reuse can present. I mean, it seems natural to reuse the heat or not waste the heat you're saving or you're benefiting in some way. I also think in the US, though, that there are huge opportunities for heat reuse, and it needs to be considered as a way to manage the backlash against data centers that we're seeing happening all over. Heat reuse gives a great opportunity to give back to the communities. So I think makes sense for our data centers as they're building to always look for those opportunities that they might be able to provide back for, whether it's agriculture or swimming pools in schools, or ideally district heating, which we don't have as readily as Europe, which makes it a little bit of a challenge to come up with a one size fits all. But it's, I've also heard of opportunities for desalination, and there might be opportunities to reuse the heat in inside the data center for other sources that other loops that they need to run. I mean, it's an energy source. So if you're able to capture all of that heat and use it, there's lots of benefits. But I think in the US, one of the things to think about is how heat reuse can be a way to engage with communities and provide back to those communities.
I have a follow-up question for you. I think that folks know that data center operators are typically adverse to policies or regulations of any kind. Why is it a good idea to engage with policymakers in this space? And how is the industry going to improve as a whole with that?
So the deal with policymakers is you cannot engage them, but that doesn't mean that they're not going to get engaged. There's going to be forces that will bring them along at some point. And again, this is a great example, is to talk about in the US, for a long time, nobody knew what data centers were, right? They were just these big silent boxes that operated in various suburbs, mostly in Virginia, not far from where I live. And everyone just didn't know that they could operate in secret. They were happy. People were, not worse for the wear, not knowing what they were. Well, that's gone. And that's because of this, a lot of what Mohan and Kelly talked about, the increased power demands of the data center have made them no longer able to just operate in secret. Everybody's aware now that they're there, that they're eating up power, and it's leading to significant pushback from communities concerned about how that's going to impact their access to water and power. And as a result, policymakers, if they don't have an easy solution, often the answer is just going to be no. So that's a simplistic case scenario, but not having the facts isn't going to prevent a policymaker from making a policy. So it's always best to educate policymakers so that they can make informed decisions. And the sooner that you can educate, the better, especially to make sure industry's needs are met and that it's able to meet all of the demands that it has. It's going to need policymaker support, especially in those local communities. So, yeah, that's our pitch: is get it. Don't wait. There's plenty of projects that have gotten far down the road, and just to at the last minute not be able to move forward because they didn't have all the support they thought. So it's both, and I just add, it's not just policymakers, it's also community engagement, right? You need to make that combination is part of the effort in any builds in this new world of high demand for energy and water that we see.
Thank you. So, I was reflecting on the conversation associated with cooling and the various kinds of technologies that can come into play in solving the esoteric question about what to do with all of this heat. Every cooling method has its own hurdles. Cold plate has hot spots. Immersion has material compatibility that everybody debates endlessly. And then, of course, there's tons of controversies around two-phase fluids. When you look at these challenges, which of the problems do you see as most urgent to solve and which are most solvable?
So I can take that to start. We need to be focused on all of them simultaneously, honestly, because all of these solutions and all of these technologies are going to have to be used in a safe way as we continue to scale AI. That's really the honest truth of it. And so I think that's one of the reasons why all three of us are engaged within the Open Compute Project, and we're engaged in different groups and different levels. For me personally, I chair the industry liaison team as part of the immersion project, which is under the cooling environments. And so our team is really focused on the bilateral communication between standards bodies and OCP, which has all the technical experts, to really facilitate that we're getting the right input from the technical experts into the standards that are going to support these technologies. One of the clear insights for me that one of my colleagues made during the conference, which is something we all know, but it was just explained so eloquently, and that was from Amy Short from Denver DataWorks. She said that really these solutions are being deployed faster than we can create the standards for them. And so I just think that's really important. And if you look across the OCP landscape, particularly within the cooling environments, you have groups that are really working, and you have industry coming together to really work on these key challenges. And so I think we need to be able to have solutions so that all of these technologies can be supported in a safe and sustainable way.
So, okay, so it's going to take all three, and I get that. But like one of the ones that comes into my mind is, two-phase needing to work on a cleaner path for chemistries. You are the experts. You're the technologist. Is that even possible?
Yes, yeah, I think so. First of all, quick background as to why don't we just stay with single phase? When we say single phase, we really mean water.
Mm-hmm.
So water with it's mixed with some other chemical for antifreeze and various other purposes. But water is a great coolant. But the problem with water is, as you know, electronics and water don't mix. Leaks are a huge problem. So you look at other chemicals, and now let's go to the other extreme, which is like a two-phase immersion type solution. Now, the issue is those chemicals tend to be fluorocarbons, and many of them tend to be what is classified as PFAS, which I'm sure Erica can talk more eloquently than I can. For that matter, Kelly, she has a PhD in chemistry, right? So, so the those PFAS chemicals, obviously there is a balance that the government needs to strike, or any lawmaker needs to strike, between efficiency of cooling and impact to the environment in general. But I think the path that we are on today, which is to go look at alternatives to these PFAS chemicals in terms of looking at other refrigerants that are more suited, will lead us there. I think we always do better when there is a constraint on top of us, and that's exactly where we are. The clock is ticking on us. I'm sure Erica can again tell you the exact timeline, but it's about 2 years before we find this chemical that's going to give us let us have our cake and eat it too, if you will.
Now, the report stresses the need for industry-wide collaboration, and that really spoke to me from my history in the industry. Where is coordination happening most effectively today, and where are the biggest gaps in aligning the ecosystem?
I'd say there's no question that everything is different now, right? Before you had talked about you could kind of design the data center buildings, and there'd be real estate developers, and then there'd be the IT team would come in afterwards and stick in the equipment, and they never really needed to talk to each other. And and now all of the kind of specs and the RFPs for data centers are all kind of set, and there's a way that everyone has built them for years, and it felt like that's the way it needed to keep going. And this is another area where it's become incredibly challenging, because today, with the chips that Kelly and Mohan described and their incredible heat densities, really for the most efficient and effective way to work, you need to design the entire data center from like the chip all the way to the grid, because you need to be thinking about every part of how this is going to work. And then at the end of the day, do you have enough power to even make this happen? And so that requires collaboration in so many ways, right? It requires increased collaboration within companies. It requires increased collaboration between technologists and managers and leaders. And then it requires coordination and across communities. So I'd say it's because of the demand, it's moving so quickly. It is happening in a lot of places. So that's good news. Like we see it's just forced by necessity. But there are some, particular organizations, I think, that are doing a notable job of this. And, I see OCP just as one of those areas that is just bringing together a wide scope of players to talk. It's, it's open so everyone can join. But then I also see so many other organizations, Data Center Dynamics, Data Center World, and then I think every week there's a data center conference that somebody is putting together, and it is leading to increased discussion and collaboration. And then there's, enter the Liquid Cooling Coalition, the AI Infrastructure Coalition. What we're trying to do is just bring in that policy piece and pay close attention to the technical side of things, because I don't think there's a lot of organizations. There are a lot of tech trade associations. I used to work for one of them that does a great job of paying attention to everything when it gets to that policy level. But what we're trying to do is actually, given how quickly things are evolving, is get to know all the players and work with all of the incoming entrance to this field, because data centers are changing. They now need plumbing. They never needed that before. So there's all these new market entrants. So just keeping track of that so we can get in early and be a place to coordinate the entire ecosystem and bring players together. And then, as I say, at the same time, educate, advocate, and coordinate industries is our role, and with policymakers as well. So,
And Allison,
there's no single answer, I guess, but Kelly, Mohan, what do you see?
Yeah, I just wanted to add to that, because that's why I think that we need to have these kinds of conversations, Allison. This is one of the driving factors behind the paper that we wrote. I had an initial draft and I felt it was missing some important pieces to that and important experts. And so I brought in Mohan and Erica to really bring in their perspectives. And I think that's what you see, is that we're starting to see these alignments across the industry, where you have different people with different expertise coming together to support this AI boom. Because if you don't have the right experts and you don't have the right technology and coming together and collaborating, we just won't be able to solve all these challenges, because we're just being hit with innovation happening every couple of months, versus we had, prior to that, we were innovating on roughly a 2-year cadence. And that's just gone out the window. And so I think you have to work together to be able to support what's going to be needed for AI, which is not going away. We're coming, last year we were all talking about generative AI. This year we're talking about agentic AI. And after that, it's going to be the robots. So we need to be able to come together to be able to solve all these challenges.
You know that everybody that's listening is now fearing for Terminator based on your comments about after that it's going to be the robots, but we won't go there. This has been a fantastic conversation, and it's a fantastic paper. If you haven't read it yet, please do. It's foundational, I think, as we head into the second half of 2025 to see what the industry is grappling with in terms of AI data centers. I'm going to ask you guys one last question. If we think 5 to 10 years ahead, what's the most important infrastructure investment that data center leaders should be making today to support the next generation of AI workloads? Is there one that comes to mind?
I'll jump in unusually on this, since I'm not the technologist, but it's from my perspective, and what we hear is the number one concern is actually power, right? If you don't figure out how to run your data center, because all of the existing infrastructure was built for not needing this kind of energy. So how are you going to get the electrons you need to power those data centers? That's the number one question. And we've got a grid that was built for a different industrial revolution. This is a whole new game, and requires maybe a whole new grid, but we don't have a whole new grid. And so that's something that we are working on, and that does require policy.
Absolutely.
Is how do we fix this, and how do we fix it fast? So those are my 2 cents.
I like your answer, Erica. Kelly and Mohan, do you want to provide your perspectives as well?
Yeah, so I think Eric is absolutely right. Number one issue is power. If you can get to the power, there is no data center to be had. That's a fundamental issue, and leading the pathway to power. So Kelly and I live in the Pacific Northwest. There are lots of hydroelectric power. Therefore, there's lots of data centers right next to those dams. So it's natural people gravitate towards where that abundant power is readily available. And as soon as you put power, guess what? You generated heat, and somebody has to take that heat out. I view data center as a series of heat exchangers. Eventually, you have to heat exchange into Mother Nature, and invariably today that involves water. So this is why you also see these data centers located near some place where there is available source of water. And so I think those two are the big challenges that face data centers all the time: power and water.
So, Kelly, we've got power and water.
So
What is your
I'll add
investment?
to it. It's the infrastructure, right? So those are the 1 and 2, and then 3 would be the infrastructure, because the infrastructure does, that would take all of, the power and the water that's needed for providing the power to support the IT and the cooling. And then how do what do you do with the heat that's generated? Well, you need to have the right infrastructure in place. And so that means a redesign of the data center. That means including, central distribution units within your data center to support liquid cooling. That's the first piece. Whether you're doing an immersion or a cold plate technology, you need to have those CDUs designed into the data center. Then you're talking about the fluids and having the right protocols for servicing and providing maintenance to the data center, depending on the type of cooling that you're doing. And then also we talked a little bit about heat reuse. So then having the right infrastructure in place to really make the best use of that heat that's generated from the data center, so that we can be sustainable and we're not adding issues with climate change. So I would say that would be the third piece.
And you guys didn't even touch on accelerated computing faster than Moore's law, accelerating every standard in the data center faster than it's ever been done before, re-architecting networks, re-architecting data pipelines. Everything is changing from the grid to the chip. So exciting times in AI computing. Thank you so much to the 3 of you for being here today. One final question: where can folks continue the conversation with each one of you? Mohan, why don't you go first again?
I'm on LinkedIn, so you can connect me at Mohan J. Kumar, and feel free to ask me any questions, comments, criticisms. They're all welcome.
Erica?
LinkedIn, and then also at the Liquid Cooling Coalition, so www.lccoalition.com.
And Kelly?
I'm also on LinkedIn, and you can find me at www.avayla.net.
Thank you to the 3 of you for being here today. It was a great conversation.